Yes. Yes, for which equation you are getting it out?
Sir, I was having difficulty understanding like how to do these kind of questions.
Okay.
Like if you could tell me of little bit.
Okay. The thing is that we are discussing about the we can solve first one. Okay, this is the basically circuit. Now I have to identify the magnitude of transfer function at omega is equal to 4 omega. Okay, so and given that as is equal to omega u by s, that means this particularly is the known item. Known item. Why it is non-ideal op-amp? Because for the ideal op-amp, we generally consider the AS is equal to infinite. Okay, the feedback operation amplifier gain will be now this particularly is called the V, and V out is nothing but equal to the AS time V difference voltage. Okay, AS time V. Now, what is the VD? That is A naught is equal to AS time V positive voltage minus. This is a we are considering that this is the V1. Okay, so if I check this one, so AS. Now, what is the V positive voltage? V positive voltage is the ground. Positive terminal is grounded, so V positive is C. And what is V negative voltage? V negative voltage is that is equal to the minus AS time. Okay. Now apply the KCL equation. So the current that is coming from this one, it will be going in this direction. Okay, in this direction the current is in this direction the current is. Now similarly the current that is coming in this direction, it will be divided in this one. So if I say it is I1 current, I2 current, I3 current. So what we are getting? We are getting I1 is equal to I2. So question number one. Second is I2 is equal to I3 plus I2. Question number two. Now what is I1? The current is coming from VI to V1. So VI minus V1 by R1 is equal to V1 minus V2 upon. Similarly for the question number two, V1 minus V2 upon R2 is equal to V2 minus V0 upon R3 plus V2 upon R. Still give me 2 minutes. Can you solve it now? I just come in 2 minutes.
Sure,
Okay.
sure.
Hello.
Yes, sir.
Okay. So the R1, R1, R2, R3 are the R given the question. So Vi minus V1 by R is equal to V1 minus V2 by R. Equation number one, R1 and R1 cancel out. So Vi is equal to 2 V1 plus minus V2. Equation number three. Similarly, if I put here, so V1 minus V2 by R is equal to V2 minus V0 by R plus V2 by R by 4. That is a 4R. Okay, now R cancel out. So V1 minus V2 is equal to V2 minus V0 plus 4 V2. So V1 is equal to 6 V2 minus V1. Can I put this equation in this one? So Vi is equal to 2 times 6 V2 minus V0 minus V2. So Vi is equal to 11 V2 minus 2 V0. Question number 6. Okay.
Yes, sir.
Now we have to calculate a V0 upon Vi. So Vi is equal to 2 V2 minus V0. Now what we can do? Now what we can do? Vi is equal to 11 V2 minus 2. We have to eliminate the V2 from here. Okay, so how we eliminate? Yeah, from the equation number this one. Equation number this one also. 6 we have. Seven. So that is equal to minus AS. V out is equal to minus AS times V1. Now from this one we are getting a V2. What is V2? V2 is nothing but Vi minus, sorry, 2V1 minus Vi. Okay. So I just replace this one. So Vi is equal to 11 times 2 V1 minus Vi minus 2 V0. Okay, so it is a 12 times Vi is equal to 22 times V1 minus 2 V0. Okay, and what is V1? So there is 22 times V naught upon AS with minus sign minus 2 V naught equal to 12 VI. So 12 VI is equal to minus 2 plus 12 by AS times V naught, and V naught upon VI is what? 12 upon with minus sign 12 upon 2 plus 12 AS, or equal to minus 6 upon 2 plus 6 AS. Now what is the AS? Omega U
4
by
omega.
S.
Yes.
So minus 6 upon 2 plus omega U, sorry, 6s upon omega U. Okay, so that is a V naught upon VI. If we are calculating the magnitude, so V naught upon VI is what? Magnitude is what? 6 upon root of 2 plus, sorry, 2, not 2, it is a 4 real component का square plus the imaginary component. Imaginary component is a 6 omega upon omega. This is the imaginary component.
And omega u is already 4 omega this way.
Yeah. So we just put a 66 omega square upon omega u square. So it becomes a 6 upon root of 4 plus 36. Now it is given that omega u is equal to 4 omega u. So when I put it as a 4, so it is 16. Okay, omega and omega u and omega will be cancelled. So this is the V naught upon Vi. Okay.
Yes, sir. From here it is okay. Can you please check the second question of the mock?
Now similarly we can solve all questions. Okay, only the change is there and the DC gain. Now we are getting this particularly transfer function. Now what is the DC gain of this one?
6.
Wait a minute, what we do? It is a 1 plus. Because 2 we are taking common, so it is a 1 plus 6 as.
Yes, sir. If we would have taken 4, then the answer wasn't
Yeah.
right.
One. One. Okay, can we neglect the 1 also? So it becomes a 66 into 60. 36 into 60. Okay, so it becomes a 6 upon 6 into 4. Okay. Now, what is the DC gain? V naught upon Vi. The DC gain is that when S is 0. Because S is j omega, omega is 0. So the can I represent this one is the A naught upon 1 plus S upon omega u by 6. Okay, A naught upon 1 plus S omega u by 6. So this A naught term is the magnitude of A naught is nothing but the DC gain. Okay, and if we are talking about this omega u by 6, it is the bandwidth of closed loop system. Okay.
Yes, sir, got it.
Now move to move to question number 2. I think Mach 2 I have already discussed with you. Yeah. What is the question number 2? If the turn on current of red and green LED is 1.18 volt respectively in the figure. Figure is visible or not? Oh, the figure is not there.
Yes, sir, exactly.
Okay. So I just draw the figure. The figure should be like that. This is the battery. Will be connected with R1.
Sir, your screen is not being shared.
Now it is visible.
Yes, sir.
This one. So red LED, green LED, R1, R2. Uh, the voltage is 3.2 volts. Okay, this is the figure.
Okay, okay, sir.
Anything else for this? Can I solve this question or you can do that?
Sir, the solution is not going to get provided. Like, you're not going to provide us the solution, right?
Yeah, so I
Okay,
will
so
solve it.
yeah. Can you at least give us the final solution so that we can cross check our answers?
Yeah, I can do provide that one also. That one.
Yes, please.
Okay. In the G space, I can provide that particular.
Okay, sir.
Yes, sir, that would be really helpful.
Okay. Now, if we say that the turn on voltage for 2.2 and 1.8, so that means the R LED V on for red is 2.2 volts and V on green is 1.8 volts. Okay, so we know the equation is that when I apply in the first particular branch, so 3.2 volt minus 2.2 volts divided by R. Okay, the voltage difference divided by resistance, and the current is required current is 40 milliamp. Okay, so 1 volt is equal to 40 milliampere times R. So the value of R is 1 divided by 40, or we can say 1000 divided by 40, it is at 25. So this particular resistance is 25 ohm. Okay, R1. Similarly for R2, so it is a 3.2 minus 1.8 volt divided by R2, that is equal to 40 milliampere. Okay, so R2 is what? 1.4 volt divided by 40 milliampere. So it is a 1400 divided by. So this resistance value is 35. Okay.
Yes, sir.
Now, which LED is suitable for the system and why? So we can say the green LED is suitable. Why green LED?
Because it draws less voltage.
Less voltage. It requires the less voltage. Okay. It requires the less voltage to on. Then what is the minimum battery voltage required to own both LEDs? The minimum voltage is
So we
2.2
could,
volt.
yeah. Sir, no, it would be 1.8.
Both LED.
Oh, yeah. Sorry. Yeah. 2.8.
Okay. If we provide less than 1.8 voltage, so red LED will not on and blue LED, green LED will on. Okay. So if the voltage will be greater than 2.2 voltage, 2.2 volts, red plus green both are on. Okay. If we provide a voltage from 1.8 to 2.2, only green will on. Okay, and if we provide the voltage less than 1.8 volts, that means no LED. Okay.
Yes, sir.
Yes.
Now question number 4. So the input voltage is Vi. Gm to Vi R1 C1, this voltage is V1, multiply with 1, we are getting a V0. So what is the relation between V1 and V0 is V1 if we multiply with 1, we are
Will
getting
give
the
us
V0.
about. Yes, sir.
Okay. Now what is the V1 equation? If we say this is my current source, the current will be distributed in two parts. One is this one and one is this one. So first of all, we calculate the current in C1 branch. So GM2 times VI into, how we calculate the current divider rule? The resistance of the opposite branch R1 upon R1 plus 1 by C1s. Okay, and that is equal to GM2 multiplied by the V1 into R1 C1s upon 1 plus R1 C1s. Okay, so this is the current IC1. Now, with respect to this IC1, if I calculate the V1, so V1 is nothing but IC1 multiplied by the 1 by C1s. Okay, impedance of the capacitor 1 by C1s. So if I put this one, so it becomes a GM2 times VI into R1 upon 1 plus R1 C1s. Okay, so now V1 is what? V1, if I put the V1 in place of V1, if I put the V0, so V0 is equal to GM2 times VI into R1 upon 1 plus R1 C1s. If I divide it, so V0 upon VI is equal to GM2 multiplied by the R1 upon 1 plus R1 C1s. So this is my transfer. Okay, this is my transfer function. So V0 upon Vi is Gm2 R1 upon 1 plus R1 C1s. Now V0 is what? Gm2 into R1 upon 1 plus R1 C1s. So Gm2 is 1 into 10 to the power minus 3 into R1 is 15 into 10 to the power 3 divided by 1 plus 15 into 10 to the power 3 into C1 is 0.1 into 10 to the power minus 6 times S. So it is a 15 divided by 1 plus 15 into 10 to the power minus 4S. Okay, so this is the output voltage. Okay, the frequency is not given here. So if frequency is given, we can calculate the magnitude. So V naught upon 15 upon 1 plus 225 into 10 is to the power minus 8 omega square. Okay, if frequency is given, we can calculate the V naught. Okay, and find the stability of first order filter circuit. So how we check the stability?
The root should be in the left half pole.
Left half. So if I calculate the pole of this one, so S is equal to minus 1 upon R1 C1. Now what is the value of R1 C1? 15 and 0.1. So it is a minus 1 upon 15 into 10 raised to power 3 into 0.1 into 10 raised to power minus 6. So it is equal to 1 into 15 into 10 raised to power minus 4 with minus sign. So it is a 10,000 divided by 15. So 2000 divided by 3 or minus 666.67. So the value is negative, so it is stable. Okay.
Yes, sir. Got it. Sir, can we also discuss the previous question, the question number 3, Butterworth filter? This one.
This one.
Yeah.
Okay. So I just we have to write the equation. Okay. First of all, we calculate the magnitude gain. Okay. So what is the gain? We are applying the input signal at a positive terminal. So the gain is 1 plus RF by R1. So it is a 1 plus R3 by R4. Okay. And when R3 and R4 are equal, so we can say the gain is 2. Clear?
Yes, sir.
Now second, if this is the V out voltage and it will the current will be going in this direction. So we can say, like for example, we consider that this voltage is Vx. Okay, so we consider this voltage is Vx. Okay, so what is the value of Vx? Vx is nothing but V out by 2. Because if these two
Yes,
resistors
sir.
are equal, if these two resistors are equal, so half voltage will be divided at this point, half voltage will be divided at this point.
Yes, sir.
Okay, and this Vx is nothing but this voltage. If I say that this is the V1, this is the V2, so what is the Vx is V2. So V2 is also V naught by 2. Okay, because of negative feedback, the apply the virtual ground concept, the terminal voltage, positive and negative terminal voltage should be equal. Clear?
Yes, sir.
Now we can write the equations of the current that is coming from this one. It will be going in this way and this way. Similarly, the current that is coming from this one, it will be going in this way because no current is going in this direction. So the equation is V in minus why it is not working. Okay, so V in minus V1. So V in minus V1 upon R1 is equal to V1 minus V out upon 1 by C1s plus V1 minus V2 upon R2. This is the equation number 1. Second equation is V1 minus V2 upon R2 is equal to V2 upon 1 by C2s. Okay, so V1 by R1 is equal to V2. I take this side, so 1 upon R2 plus 1 plus C2s. Okay, and V1 by R1 is equal to, I can just write a V1 is equal to R1. R2 is the LCM, so 1 plus R2 C2 plus times V2. And what is V2? It is V out by 2.
Yes.
Vx or V out by 2. Okay, so we are getting V1 is equal to R1 by R2 1 plus R2 C2s time V out by 2. Okay, so we get the equation V1 in terms of V out. Okay, so V1 in terms of V out, V2 we already calculated in terms of V out, so it is a V out by 2. Now, can I solve the first equation? So V1 in terms of V out, V2 in terms of V out, V1 in terms of V out, V1 in terms of V out. So that means this complete equation is in terms of V1 and V out. Can you calculate the transfer function now?
Yes.
Okay. Okay, so V in term will be in one side and all V out term will be the other side. Now take a common of V out and just solve it.
Sir, and then it has to be compared with that thing, that formula 1 divided by 1 plus s
Yeah,
by
yeah, yeah.
omega
Now you
pqp.
have to calculate the pole frequency. So you have to compare it 1 upon 1 plus h square upon omega p square plus s upon omega p.
Got it, sir.
Okay. So the value of omega p you will find out. Again, omega p qp you will find out. So qp is nothing but, if I say this is the x and this is the y, so y upon omega p. So it is a y by x. Okay. You can calculate by.
Yes, sir. Now it can be calculated. Yes.
So every second order filter we solve this one. Every second order filter we solve in this way.
Got it, sir.
Either we replace who is this one? Okay. So either I can replace R1 and R2 by C1 and C2 and C1 C2 by the R1 R2. Okay, so we can use the either low pass filter, high pass filter, any particular circuit will be we calculate in this way only.
Got it, sir.
Sir, I
Sir,
had a doubt.
just
Okay, please.
yeah, go ahead, Vishal.
Oh, please complete yours.
Okay, so sir, just to recall we haven't studied high pass filter in detail as we have studied low pass filter in the weeks.
Mm-hmm.
So, would that be a part of the question? Like, in if
Maybe
it's so,
I don't. Maybe I don't know actually because the question paper will be prepared more than 30 days before. So exactly, I don't know which question I am giving.
okay,
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 but if it is a if IPipe filter is also given in the question, so I think the circuit is given to you. Okay, now with this same method you can apply for the high pass filter also.
yes. So, and then it has to be compared with the similar equation, but in that the numerator would be s square by omega p square.
Uh, the numerator, yeah, exactly.
Okay, got it. Thank you.
Yeah, sir.
Mm-hmm.
I had a doubt in calculating the finite bandwidth. Can you please help me with it?
Which
I have
one?
this finite bandwidth. I have this question from week 7. Can I
Mhm.
share my screen?
Yeah, give me a second. Yes, you can share your screen.
This one, sir.
Mm-hmm.
So we have to find the value of k, and can you please solve this one?
First, we have already solved for the question 1, 2, 3. Okay, similarly.
But how are we supposed to find this thing? Like, okay, so from this circuit, I got to know about that, but how did we calculate this part? Omega b1, omega b2. That
Mm,
is what is making me go mad at.
mm, you are getting, okay. Yes, now what you are asking?
How did we calculate this one? This
Okay.
part.
Basically, the thing is that if we use a first system, okay,
Hmm.
so when we calculate the transfer function, V naught. So your transfer function V naught upon Vi is in the terms of A naught upon 1 plus S upon omega B1
It was somewhat yeah, somewhat like that
in
only.
this form. Okay. So this particularly is the bandwidth omega B1.
The transfer function.
Yeah, transfer function. If we are taking the transfer function, the transfer function should be represented in this form. So multiply of S, okay, and a reciprocal of that one is the bandwidth. Like for example, if we are getting a transfer function is like A naught upon 1 plus 4 upon RA plus RB time S. Okay, so what is the bandwidth of this one? RA plus RB by 4. Okay, similarly, we can calculate the transfer function for the second circuit also. So second circuit is V naught upon Vi is equal to A naught upon 1 plus, I just mentioned it as a 2 upon R1 plus R4 time S. Okay, for the second circuit, same method, solving the same using the same method, calculate the transfer function. Now the transfer function in this form. So what is the omega b2? For b2 is what? For second circuit, and this is the bandwidth. Okay, so now what is the value of omega b2 is r1 plus r4 divided by 2. So you have two bandwidths. Okay, now you
Yes.
know the value of r1 and r2. Can you calculate what is the relation between the omega b1 and omega b2?
Hmm.
Okay, so like for example, maybe possible the omega b1 is equal to 2 times of omega b2. For example,
I'll,
I just assume that
yeah.
omega.
Okay, then I'll try to solve this part, and if I face any issues, then I'll ping you
Yeah,
on Space.
yes, correct, correct.
Okay, sir. And one more doubt.
Yeah,
So in the
same week 7,
week 6.
week 6. Okay.
So while calculating the pole frequency, the formula was
Mhm.
1/r under root C1 C2, I guess.
Pole frequency, yeah, R C1C2.
Yeah.
Okay.
So since here the value of R is common for every resistance,
Yeah, R is common.
so if we get some other values, like for R1, R2, and R3, some other values are provided. So which
We have to calculate that one.
So which R are we supposed to consider that time?
The basically thing is that this R. We are taking this R.
This one?
This one.
Which?
First operation amplifier parallel with C.
Okay, this one.
Yeah, we are taking
This-
this one. Yeah, this one. And this
Okay.
one we are taking the RX, like for example.
Oh, okay, sir. That's it then.
Okay, that is also if you go through with the video content, that is professor also explained. If R value is not same for all particular circuit, so which one we are taking the one particular resistor we are taking R, and one particular circuit we are taking the RX.
So this should be the RX part then, which has to be considered.
In the video, it is RX or R.
No, whatever the thing is, sir. So this is the R which has to be considered, right?
Yes, yes, yes.
Okay. Okay, sir.
Now, any other doubts? No doubts?
No, sir, no
Yeah.
doubt as of now.
Okay.
So just one thing, would the question
Yeah.
paper be somewhat similar to the mock, or would it be totally a different way?
Yeah, or somehow similar to the. It is not similar to the quiz one. Okay. Somehow similar to the mock.
Okay. Okay, sir.
Okay.
Got it.
In the mock one and in the basically quiz one, there is no relation between them. But for the mock 2 and quiz 2, there is a relation.
Okay. Thank you, sir.
Yeah.
Thank you, sir.
So thank you all. All the best for your exam.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you
sir.
so much.
Thank you. Thank you.
Excuse me, sir.
Yeah.
I